Okay, so good day everyone. Our topic for today is very interesting and very important, especially for those who took up with thesis. No? Actually, when I've heard the word test of relationship, it always remind me, no, about the persons R, chi-square, t-test, and ANOVA. Again, when it comes to inferential statistics, because this will be the part of inferential statistics now. So it consists of statistical methods that are used to test hypotheses that relate to relationship between variables. So it is also important to us, no, to be familiar with the variables, no, categorical and so on. Let's say, for example, no, you might hypothesize that individuals with greater level of education tend to have higher incomes. Well, we can use descriptive statistics such as line plots as outlined in the previous discussion, no, in our and of course illustrate the relationship between two variables, and we need to use inferential statistics to more rigorously demonstrate whether or not there is a relationship between these two variables, no. Because with all inferential statistics, which particular statistical test you will depend on the nature of your data as well as the nature of your hypothesis. So again, as I mentioned, no, person correlation coefficient, or also known as persons R, no, the chi-square test, the t-test, and ANOVA will be covered in the inferential statistics. No? So to give us more actually discussions about the t-test of relationship, let us all welcome our presenter. Go ahead.
Thank you, Dean. So good morning, everyone. I'm Michael Francis Ata, and I'm here to present to you the Cramers B in managerial statistics. So Cramers B, it is an effect size measurement for the chi-square test of independence. It measures how strongly categorical fields are associated. So to use it, your variables of interest should be categorical with 2 or more unique values per category. So next, the effect size is calculated in the following manner. First, determine which field has the fewest number of categories. Second, subtract 1 from the number of categories in this field. Third, multiply the result by the total number of records. Fourth, divide the chi-square by the previous result. And lastly, take the square root. So we have here the formula for Cramer's B. So x squared is the Pearson chi-square statistic from the aforementioned test. N is the sample size involved in the test, and K is the lesser number of categories of either variable. So next is the interpretation of effect size. So if the effect size is greater than 0.2, the interpretation is weak. Although the result is statistically significant, the fields are only weakly associated. So next, 0.2 is less than the effect size or less than or equal to 0.6. The interpretation is moderate, meaning the fields are moderately associated. And lastly, if the effect size is greater than 0.6, the result is strong, meaning the fields are strongly associated. Next is to when to use the Cramers B. First, if you want to know the relationship between two variables. So if you're looking for a statistical test to look at how two variables are related, other types of analysis include testing for a difference between two variables or predicting one variable using another variable. Second, if your variables of interest are categorical, meaning a variable that describes a category that doesn't relate naturally to a number. So examples of categorical variables are eye color, city of residence, so etc. And lastly, if you have 2 or more unique values per category, To perform Cramer's B, there must be 2 or more unique values in each of your categorical variables. If there are only 2 unique values, then using Cramer's V is the same as using the pi coefficient. So we have here an example of Cramer's V. So a scientist wants to know if music preference is related to study major. So he asked 200 students, resulting in the contingency table shown below. So this table shows some quite association between music preference and study major. The frequency distributions of study are different for music preference groups. For instance, 60% of all students are different who prefer pop music study psychology. So to get the Cramer's B, our sample size is 200. So we have variables with 4 and 5 categories. So the K would be 4 less than 1, so 3. So we have 0.43 Cramer's B, which is substantial but not super high since Cramer's B has a maximum value of 1. So next is the regression coefficients. Are estimates of the unknown population parameters and describe the relationship between a predictor variable and response. So in a linear regression, coefficients are the values that multiply the predictor values. So suppose you have the following regression equation. So y is equal to 3x plus 5. So positive 3 is the coefficient, x is the predictor, and positive 5 is the constant. So here we have the relationship between predictor and response variable. So in this table, a positive sign or coefficient indicates that as the variable increases, the response variable also increases. So in a negative sign or coefficient, it indicates that as the predictor variable increases, the response variable decreases. So the size and sign of a coefficient in an equation affects its graph. So in a linear equation, the coefficient is the slope of the line. So in this graph, the coefficient and the slope is positive 5. And for this graph, the coefficients are 2 and negative 3. So next, another example for regression equation. We have the heat flux. This equation predicts the heat flux in a home based on the position of its focal point, the insolation, and the time of the day. So each coefficient estimates that the change in the mean response per unit increase x, where all other predictors are held constant. So for example, in the regression equation, if the north variable increases by 1 and the other variables remain the same, the heat flux decreases by about 22.95 on average. So next is the importance of regression coefficient. So we have the first interpretation of the ordinary regression model, the most popular technique for making predictions of a single continuous variable. It focuses on the model's coefficients with the aid of 3 concepts. So we have the statistical p-value, variables held constant, and the standardized regression coefficient. So that's the end of my presentation. Thank you for listening.
Okay, so our presenter now discuss about the correlation coefficients and an example, of course, of the person R. No? So the purpose of the correlation coefficient is to determine whether there is a significant relationship, no, between two variables, as I mentioned.